Hello guys, today welcome back to my channel, and today I will show you how to using SAP 2000 to analysis of structures. So today for the reference I will use uh, the book made by Aslam Kassimali with the title of Matrix Analysis of Structure. So the thing is, the difference of the basic structure. This book will tell you how to do the analysis of structure using the matrix method. So actually the difference is when you do the basic structure, you just got the fixed support, the force direction of the fixed support. But in the when you using the matrix method, you can get the force direction in the fixed support and the displacement of the member and also the force in the member, the force direction in the member with applying the force. So actually the matrix method is like using the stiffness of the on your member to find the output before I tell you. So for right now, I will just show you how to use SAP 2000 to find the fixed support and the displacement when applying the force in the member in the structure. So the basic is the SAP 2000 is just like a usual calculator. It's like to calculate something, but the difference is this is able 2000 is just calculate for the structure analysis. So, but the problem is like can you use this SAP 2000 to do the analysis structure? And that's how I made this video to show you how to to do the analysis of the structures. So actually this is AP 2000. Of course, you should know the basic how to find analysis of structures, but this ECP 2000 is just for like a comparison. So of course you should know the basic, but you also need to the comparison to know for if your hand calculation is right or no. So first of all, let's just jump into it. Okay, first of all, you should open your software or SAP 2000 first, and then you go to the file and choose the new model and choose the two-dimensional frames because we will do the analysis in the frames, and you should input your dimension. What you call it? It's like that lah. And then choose millimeter or in or feet, because this for me I will choose the meter here and to dimension frame. Okay, after that you should input your storage and base. Storage is the y axis and the base is x axis. You actually can see this the height and the width of your frame. So because in this example is goes to two stories, like 1 2, so there's one and two story, so we choose the two stories and just one base. Okay, so we got two stories and one base, and for each stories is 6 meter for one stories. So we put here 6 meter, and for the width is 9 meter. If I draw, oh yeah, it's 9 meter. That just press OK here. Now we got the basic structures. but but that's not our structure here. You got like this, have an angle here, so you can just delete all this. You can block here all and press delete, and just boot again your frame here. So you can just actually, first of all, okay, you can just do that. When you got this, you can actually, when you determine your dimension of your structure, you should define your structure, your what is it, the data engineering, the data of your material, because here you can look here, it's you got the the E is 30 GPA, 30 GPA, and yeah, like that lah. Yeah, the properties of your member or your beam, your member, right here. Properties. You for to change your properties, you can just go define and go to the material first. Okay, and put the add new material. Add new material here and choose the material of cheaper, material of type. We don't know what our material, the type of material is, steel or concrete. So we just use the other option here. And actually you can ignore this. You just need to go to the modulus of elasticity. Go to the shift and enter. And then you first of all you should input your I forget about this, the unit. Oh yeah, the units of your properties. So for here I will just the kilonewton here, and look again. You got 30 gigapascal. So I go for 30 because it's kilonewton. So it goes to 1, 2, 3. 1, 2, 3. Okay, that's giganewton. Okay, press OK, and you got the modulus of elasticity. So we can just ignore this, like a Gaussian ratio and coefficient of thermal expansion or shear modulus, because we just use this modulus of elasticity. So you can just click OK. Actually I will change the name first. Modify. I will choose like example material. Okay, press OK. Okay, we done for the material first, and the second is we should define our section properties. Go to the section properties and going to the frame section, you need to add new property, because we don't know the section of our member, because you can just going to the press C and choose the other and choose the general. So in this, because we just need focus into the area of section and the moment of inertia, so we just need to change the cross section here. You got press the shift plus enter. Okay, shift plus enter, remember, shift plus enter. Okay, don't forget that. And then after you press the shift enter, look again, the unit, it goes to the millimeter. Press the millimeter here. Actually if you just change this one, you didn't change the unit before you put before. All right, it's just like for this one, just for this one only, so you don't need to worry about the before or the unit before. So go, because this millimeter, go choose the millimeter here and go to the formula. So we got 75,000. Okay, right, press OK, and we got okay, we got, so like this will be convert into the matter. Okay, after we done for the cross-sectional properties, we got the modulus, the moment of inertia. So you got the moment of inertia here. Press shift enter, look again the unit millimeter. Okay, and just like, you know, put the number. It's 4.8. 1 2 3 1 2 3 1 2. Okay, that's okay here, and we got the number here. Okay, so after that, we should input these two moment of inertia. Just put the same. It's not will affect the. It's not. It's not have the effect for the output. So we can say it's okay. It's okay here, and we should put the section name. The material properties. I'm sorry. The example section. Actually, it's not. Just choose the what you want. Okay. So after you put the section name, section properties. Okay, and you should choose the material. We got the example material before. Press this and choose the OK. Okay, and press the OK again. And now we can do build our frame. I'm sorry, it's not responding. Okay, the frame here. Choose this section and choose this example section we defined before the properties of example section. Okay, and just can close this one, and now we can design our structure here. Like goes this 6 meter. If you it's this 6 meter. Well, I can see it's the 6 meter. You can just look here in here. Okay, this is the point of your pointer, grid point. See, the z is 0, and when you're going to the up, it's going 6. So you can tell it's a 6 meter here, and it's 12. And when you go here, it's going to 4.5, which is this linear point is minus 4.5, so it's 9 meter. Okay, if you don't know how to define, how to look, if it is right, if the number is right, here you can just look at here. So back to before, press the draw the frame example session. Okay, and just do this. Okay, put here, we should put here again, and we got in here too. So there you go. So the same, right? I will do reject. Okay, that's right. Okay, after that, this is the fixed support. Okay, you got the fixed support in the under of the member here. You can just go to the assign. I'm sorry. Yeah. Oh, I'm sorry. You should press your frame first, like there. Press the grid point here. Assign. Push join. Choose the join and choose the restraint. Here, there's a restraint, the type of restraint, because it's fixed. So you should press here, fix. Okay, and choose OK here, and do again here. To press the grid point first, and go to the assign and join, and choose the restraint. Press OK. Okay, you should choose this. Okay, all checklist. Okay, and press OK. So there you go. You got the two fixed support here. Okay, two fixed support here, and the next step, we should there's a load assigned on the member. Okay, on the join and the member here. So how do we assign our load? First of all, we go to do the load of the join. Press grid point here and assign here, join load, push and force. So in here we got Jawa Barat ya. Okay. Okay, and actually you don't need here. For the fast, yeah, it's for like a manual assign. Okay, just choose join and join load here and do the force and put the direction of your force because it goes here. So and this in this section is x axis, so we choose the force global x and choose the magnitude. Okay, this 80 kilonewton, go to 80 kilonewton, choose the add existing load. Okay, and press OK. There you go, you got the force 80 kilonewton into the x-axis, the positive x-axis, and then you choose this grip point again. And for the like simple ways to assign your load, choose the grid point, right click, okay, yes, right click, choose press the right click, okay, yeah, right click, choose the loads here and choose the assign load. Okay, for the assign load, choose the join force because it's a force. Where you can choose a ground displacement if the that's the next step, the advanced one. Okay, for the displacement, for this one I will use join force first, and like that we got the window like before. So look again for the magnitude. Okay, 40, choose the 40 kilonewton, choose the add to existing load. Okay, add existing load, and why you should press the add to existing load, because if you like there's a force again in this member and you choose the replace existing load, so the force in the apply in this member before it will going to remove. So you should add, you look this option first. Okay, choose the add to existing loads. After that, okay, press OK, and for the loop you can just update display, and there you go, got the force. Okay, for that we have this one, the 100 kilonewton per meter. Okay, so you need to press here again. Okay, I will do like a simple basic again, the basic ways to assign your load. Press this frame, press this member, and press choose the assign, select the frame, I mean frame loads. Yeah, because the force, the type of force is distribution. You choose distribution here, and this because this distribution load is uniform. Okay, you can just press, you should remove this first. I'm sorry, just delete it. Okay, and choose this, the uniform load is the magnitude is 12 kilonewton. Yeah, 12 kilonewton, and choose the add to existing load. And for the, you need to look. Okay, you need to be careful in this section. Okay, this one. Okay, here is the direction of this force, the distributed force is here, right? Like have the angle, the normal of your member. So if you like, if you should define your coordinate system and the direction. If you choose the global and just the gravity, you know, gravity is going to the what you can say, like normal, okay, but it's going to the downward. Okay, I don't know. Yeah, you should know the direction of gravity, right? And there's x, y, z. If you choose the global and choose the like z axis, it's just going the force of your member is will going to the upward here, going to upward. I will show you. Okay, when I press OK, there you go, it's going to the up the Z direction. So how to change the direction into the normal of the member? Okay, press again here. Okay, we should modify again our loads here, assign load like before, distribute load. Okay, here, okay, the load is okay. In here you should choose the coordinate system into change into the local coordinate system, and the direction, you know, the direction of coordinate system is the one going to the horizontal, and 2 is to the direction of 2 is upward, vertical, I mean vertical, and the direction 3 is going to what is called, going to the front, right? The direction to the front, like maybe you can imagine the direction 1 is x axis, the direction 2 is the y axis, and the direction 3 is into the z axis. Okay, so in here the local, we want to into the, you know, if we imagine this is a y axis and this is the x axis, you need to change into the y axis, so you should change the direction into 2 direction. If you still don't know, you should do a research, look into the go find a reference of the local coordinate system for to better know why I tell, because I I'm, you know, yeah, but you should look for here. Okay, because we want to the going to the normal of the member, the direction into the normal of the member. Choose choose the local coordinate system and goes to 2, and okay, because we want to replace these loads, because this load is wrong, so press OK, and here look, there you go, it's going to the normal of the member, right? Okay, right, press OK, there you go. So we got our load, there you go, for 80 and 12 kilonewton per meter. Okay, okay, and then it's same, like there's no difference. Okay, after that, first of all, after we put the dimension of our frame, load, and support, okay, and the material section properties, and next step we should first of all we should define our load pattern here. Just go here, press 0, okay, modify load pattern, and press OK. There you go. Whoa. Oh no, it's going to processing. Okay, I will choose again. Okay, no, this 0. What? What the fuck? There you go. Okay. What? Hello. I'm sorry. A second, please. There you go. Okay. Press 0. Okay. Modify. Press OK. Okay. There you go. After that, after we define the load pattern here, we go to the analysis. Set the analysis option. We want the plane frame, okay, because we will 2 dimension of plane frame, not a UH, UJ, UZ. No, we just need X and Z plane, okay, because this one is X and Z plane. Press this plane frame, press OK. Then going to the analysis, run the analysis. The model, we don't need the model, so just the run or do not run case for not running this model, okay, because this action is running. So we just do run and press and go to the run now. Okay, to that Okay, it's going to the processing. At a time, need a patient. Okay, we just for save example. Okay, press save, and there you go. The uh, the the output of your analysis going to the XZ view. Okay. So to find the fixed support, you want to look the what is the force reaction, what is the magnitude of the force reaction. Go to here, so in force stresses, press join here, join reaction force. Okay, and just click OK here. There you go, you got the magnitude of your force reaction in the support in your your fixed support here. So we can do a comparison here. The result is here. Look, the 81.94. Okay. Yeah, you get it's the same. It's the same. Okay, same. Look, okay, 105, 100. Okay, 157. Okay, 49, 48. Okay, just the tolerance is low here. Okay, there you go, you got the your structure. Okay, your fixed support. If you want to look for how much the displacement, then just go here. Okay, press here, and wet shadow for the initial and the final displacement. There you go. Can just click here. There you go. You got the U1 and U3 and R2. I think is a global or I don't know, global or local. Because there are two type of displacement and two type of force. Yeah, like global force and local force, and global displacement and local displacement. Okay, yeah. Okay. It's like that. Okay, and just look here. For the example here, you got the U1. U1 is 0.02, 0.02, and U3 is 0.0007. Where's the displacement here? But we see the displacement. Oh my god. Yeah, actually, you can just for the compression you just need look the force displacement. I mean the force reaction in your support. If it's right, of course the apa what the displacement is will follow the fixed support. Okay, so it will affect the fixed support. So it will the same. It's the magnitude will be right. Okay, will be the correct number. Okay. Actually, I still don't know to find the moment in the moment in the moment on the fixed support, because in the fixed support we got three type of force reaction: normal reaction, and the vertical reaction or horizontal reaction, and the moment reaction. But I still cannot find how to find the moment reaction. But of course, it will follow the force reaction if it, the magnitude of force reaction of force reaction force in the phase support. So if your magnitude of force reaction force is correct, of course the moment inertia, the magnitude of moment inertia will be correct too. Okay. Yeah, I still don't know how to find the moment inertia. Yeah. So yeah, actually, okay. So that's it. Okay. If you get yeah, well, that's it. Okay. Okay. Thank you guys for watching. Don't forget to like and subscribe. And if you have a question, you can just ask into the comment below. Okay. Anything else? Very good. See you next time.